Hello everyone, welcome to the video demonstration of our project enhancing humanoid robot functionality through vision-based navigation with fall recovery and object manipulation. This is the design of the humanoid robot. Metal gear servo motors are used for each joint for enhanced torque. The robot has a total of 20 degrees of freedoms, 12 for legs, 6 for arms, 1 for torso and 1 for neck. The torso has two ESP32 cams for stereo vision and has enough space to fit the required circuits. All the parts of the robot were 3D printed and assembled together to build the robot.
First of all, let's simulate the forward walking motion. As you can see, the robot walks in a balanced kite cycle towards the object. There was no instability issue. And now it's time for picking up. The robot picks up the object in a balanced way by balancing its center of gravity. After picking up the object, it has to execute its next step in the simulation. The next step is the sideways movement. The sideways movement is also implemented by balancing the center of gravity. But in the real world, the robot could not bend all the way, so the object had to be placed in an elevated position. So the robot successfully picks and drops the object in an elevated position as well.
The cube dataset was annotated in RoboFlow. The dataset was split into train, validation, and test set. The distribution of train, validation, and test set is shown here. The YOLO V8 was trained on this dataset. Only one class of the object was given to reduce the implementation complexity and processing overhead. The graph of training and validation losses over number of epoch shows that model trained on 50 number of epochs produce an acceptable result.
For the distance estimation, a new model was trained on the cube dataset, and the PT extension file thus obtained was converted to the ONNX extension file, and the file was imported in the ONNX runtime to predict the cube object. The calibration was already done with the coffee bottle dataset by taking the two known distances. Using the same calibration parameters, the distance estimation was tested on the cube by placing the cube at 28 and 39 centimeters, for which the stereo camera setup predicted it to be 28 and 36 centimeter, which is quite accurate. Now for walking simulation, on using the actual data from the simulation, the robot was having an issue moving from one frame to another stably. So some intermediate frames were added and some adjustments were made so that the robot was transitioning from one frame to another smoothly without any issue, completing the guide cycle. Also for the pickup simulation, with manual adjustments, the robot's pick and drop motion was also working, but the robot cannot bend too much to pick the object.